Hi, here we are in Chapter 3, Section 5. The section's titled Parallel Lines and Triangles. The first thing that comes up is the triangle angle sum theorem, and yes, you're welcome to call it by its name. And what it says is the three angles of a triangle will always add up to be 180 degrees. This is going to be a very important theorem for you, so please keep it in mind. Next, we have a definition, and that definition is for an exterior angle. It's formed by extending the side of a triangle. Its sides contain a side of the triangle and an extension of another side of the triangle. So if we take a look in the picture, angle 2 is an exterior angle. And angle 2, as you can see, is being formed by extending side segment CB, and the other side of angle 2 is side segment BD. In the picture, angle C and angle D are the remote interior angles related to exterior angle 2. That means when you look at angle 2, the interior angles that are far away from it are angle C and D. When you think of remote, think of the remote control from your TV, which controls the TV from a distance. You go camping in a remote location. You're far away from civilization. So, again, remote interior angles are the two interior angles that are far away from your exterior angle. Okay? Each exterior angle forms a linear pair with an interior angle of the triangle, and we know linear pairs are supplementary, so that's an important bit of information. Then at the bottom of the page, you'll see the triangle exterior angle theorem. Okay, so what that theorem says is anytime you have an exterior angle on a triangle, it's equal to the sum of its two remote interiors. So angle 3 in this picture is equal to angle B plus angle D, okay? And we'll go ahead and just put a couple marks on there. They're not congruent. I didn't mark them as such, but we know those are the important angles to us. So we want to mark them so we know that they're the important ones. All right, we're moving on to page 2 and some examples. Okay, here we are on page 2 where you'll find some examples. We're going to go ahead and start with example C. We'll work on the other examples during class. So in example C, you can see that you have a pair of parallel lines. So you want to go ahead. They've been marked as parallel, but as you guys know, I like to make those lines a different color. Then anytime we have parallel lines, we should be looking for special angles, and as you can see here, we have some very nice alternate interior angles happening. So because of alternate interior angles, we can say that angle W must be equal to 50 degrees. Now, once W is marked as 50 degrees, then the only thing you're missing is the third angle of this triangle, and by the triangle angle sum theorem, we can subtract this from 180 and end up with Z is equal to 50 degrees also. Then, of course, old information kicks in. These two angles are vertical angles, and therefore they must be congruent. So Y must also be 50 degrees. Again, you now have two angles of this triangle labeled. Those two angles are adding up to 100 degrees, and that leaves 80 degrees for the last angle. So X is 80 degrees, and we answered all the questions. Okay, moving on to example D. In example D, my first question to you would be, are these two lines parallel? Is this line parallel to this one? And if we take a look here and we look at our alternate interior angles that are formed right here and right here, since our alternate interior angles are not congruent, those two lines are not parallel. But we do still have triangles that are formed. So in this upper triangle, we have 50 degrees and 60. That adds up to 110, and that leaves 70 degrees for this angle. You can also see that this angle forms a linear pair with x, and that turns out to be 110 degrees since linear pairs are supplementary. There is another option here though. Angle x is an exterior angle for this big triangle. The exterior angle is equal to the sum of the two remote interiors, and 50 plus 60 is 110. So no matter how you stack it, the numbers are what they're going to be. So at this point, I also have vertical angles, so I can fill in that this is 70. I now have two angles of my triangle. These are adding up to 115, and that leaves 65 degrees for my last angle. Okay, the last example we're going to do on this page is example F. And this is a situation where you definitely want to use the triangle exterior angle theorem. Again, it says that the exterior angle of a triangle is equal to the sum of the two remote interiors, which in this case would be 100 plus x. And then you're just going to go ahead and do your algebra and find out that x is 50. And if x, and that's all you had to do was find x was 50, and we'll move on to page 3 now. Okay, we're on page 3 of the chapter 3 section 5 packet, and we're looking at example G, 1G to be exact. And as you can see in this example, we have a pair of parallel lines. So we're going to go ahead and make those pink. Pink is my color for today. And anytime you have parallel lines, you should look for special angles, and we can see here we have a very nice alternate interior angle situation happening. And therefore, my alternate interior angles are congruent by the alternate interior angle theorem. So x turns out to be 60. We go ahead and we write that on the picture. At this point, my right triangle has two of the angles labeled, a 90 and a 60, that's 150, and that leaves 30 degrees. You can also find that 30 degrees because if a line is perpendicular to one parallel line, then it must be perpendicular to the other parallel line, and that means that y must be 30 degrees in order to make this a right angle. Okay, the last example we're going to look at on this page is J. And J just asks you to find the measures of the angles of the triangle. So we know that by the triangle angle sum theorem, that if I add together the three angles of the triangle, I will end up with 180 degrees. Okay, we're going to do a little bit of video magic here. Hold on a second. Voila. The problem is done, and x equals 21, but be careful, it didn't ask you to find x, it asked you to find the measures of the angles of the triangle. So at this point, you want to take this number and substitute it back into the three angles. So that means this angle must be 21 degrees, this angle must be 23 degrees, and then this angle, that's a lot of thinking here, I'm going to go ahead and say these two add up to be 44. Subtracted from 180 will give us 136 degrees, which hopefully is the same thing we get when we plug 21 in. Okay, so be careful and make sure you're following directions, and let's look at page 4. Hi, we're on page 4 of chapter 3, section 5, and we're looking at example 2, which goes along with this picture right here. It's asking us in this picture which of the numbered angles are exterior angles. And if you take a look, we have a triangle being formed by angle 1, angle 2, and angle 3. Remember, exterior angles are extensions of the sides of the triangle. So take a second, think about it, and see what you come up with for the exterior angles. Okay, hopefully you thought about it a little bit. And if you take a look, the angles that are acting as exterior angles are angle 4, angle 6, angle 10, and angle 8. Okay? Then it asks you to name the remote interior angles for each exterior angle. Okay, so the remote interior angles are the angles that are far away from the exterior angle. So take a second and write that down. Okay, I've written down the remote interior angles that go with the first three exterior angles, and then for the last one we'll take a look at it. With angle 8, which is outside the triangle right here, forming a linear pair with angle 3, the interior angles that are far away from angle 8 are angle 1 and angle 2. Okay, the next question asks, which two exterior angles share the same remote interior angles? And as you can see by your listing here, that would be angle 4 and angle 6. Okay, we're going to stop right here and I will see you in class.